For years, there's been this silent war raging in the world of big data. It's been a battle between three titans, Hudi, Delta Lake, and Iceberg, all fighting to become the one true format for the data lakehouse. But here's the thing. In a really surprising twist, that war is now over. So how did this fierce battle end? Not with a clear winner, but with a truce. Well, let's get into it. And it all really starts with this one question. How on earth did we take the data lake, which, let's be honest, was notoriously messy, often called a data swamp, and somehow give it the reliability and the speed of a high-performance database? The answer, it turns out, lies in this revolutionary piece of technology that all three of our titans are built on. All right, so here's our game plan. We're going to start with the problems of those old-school data lakes, then see how the Lakehouse revolution came in and fixed things. We'll meet our three titans, compare their core philosophies, and then get to the really juicy part, the surprising truths in the format wars. And finally, we'll wrap up with how you can actually choose the right format for your own needs. Okay, let's dive into part one, the problem with data lakes. They were supposed to be this promised land for big data, but for a lot of companies, they just turned into a messy data swamp. So, the original data lakes, the ones built on Apache Hive, had some massive flaws. The biggest one? No ACID transactions. Imagine a bank transfer where the money leaves your account, but the job fails before it arrives at the other end. In an old data lake, that data would just be corrupted, gone. On top of that, you couldn't easily change your table structure, queries were painfully slow, and doing simple updates or deletes was practically impossible. It was, in a word, chaos. So how did we fix this mess? Well, that brings us right to section 2, the Lakehouse revolution. This is all about bringing some much-needed order to all that chaos. The solution was this brilliant invention called the Open Table Format, or OTF. And here's the part that's absolutely crucial to get. An OTF is not a new file format like Parquet or ORC. Nope. Instead, it's an intelligent metadata layer. Think of it like a super smart index or a table of contents that sits on top of all your data files, and it tells your query engines exactly what to read and how to read it. And this one invention gives the data lake actual superpowers. Suddenly, you've got those critical ACID transactions for reliability. You get time travel, which lets you query your data as it looked yesterday, or last month, or last year. It's absolutely incredible for debugging and auditing. Plus, you can change your tables without breaking everything, and you can scale to petabytes of data without your performance just grinding to a halt. All three of our titans, Hudi, Delta, and Iceberg, share these same core powers. And this brings us to section 3. Let's meet these three titans. Because even though they share the same fundamental powers, they have very different personalities, and a lot of that is shaped by where they came from. First up, we've got Apache Hudi. Now, Hudi was born at Uber, and it was built to handle the absolutely insane volume of streaming data coming from a global ride-sharing network. So its DNA is all about high-speed, low-latency writes and updates. This makes it a real specialist for streaming and for change data capture, or CDC, which is all about tracking real-time changes from your databases. Next, there's Delta Lake. This one came out of Databricks, and you should really think of it as the ecosystem champion. It is designed from the ground up for a totally seamless, deeply integrated experience right inside the world of Apache Spark. If Spark is your main tool, Delta Lake just feels like a natural extension of it. Everything just works. And finally, we have Apache Iceberg. Iceberg was born at Netflix, where they needed to manage their absolutely massive petabyte-scale analytical tables. So Iceberg is like the universal diplomat of the group. It was designed from day one with correctness, absolute reliability, and engine neutrality in mind, with the big goal of becoming a true open standard that the whole industry could rally behind. So, these different origins, they led to very different answers to the same really hard problems. And that brings us to section 4, where we'll compare their core philosophies. Okay, one of the most crucial differences is how they handle updates. The simple approach is called copy on write, where you literally rewrite an entire data file just to change a single record. This makes your reads really fast, but of course, writes are slower. The alternative is merge on read, where you just quickly jot down any changes into a separate little log file. This makes your writes super fast, but it does require a little bit of merging work when you go to read the data. Now, what's really interesting here is that Hudi was actually built with both of these options from day one, while Delta and Iceberg added their merge on read-like features a bit later on. So what about when you have multiple jobs trying to write data at the exact same time? Well, Hudi has by far the most sophisticated system, with multiple concurrency control modes all designed to stop writers from blocking each other, especially in these really complex high-speed streaming situations. Iceberg, on the other hand, true to its diplomatic nature, has this beautifully simple model called optimistic concurrency. Basically, the first writer to commit their changes wins, and any others just retry. It's this elegant simplicity that allows it to work so well with so many different engines. But this really shows off Iceberg's true superpower, its whole approach to partitioning. See, Iceberg completely hides the messy physical folder structure from you, the user. You can just ask for data from a specific date, and Iceberg just finds it. You don't need to know how it's organized under the hood. And even better, you can change that organization later on, say from daily to monthly folders, without rewriting a single byte of old data. It is an absolute game changer for long-term table maintenance. So after seeing all this competition, you'd think one of them would eventually win, right? But that is not what happened. And this brings us to section 5, and the major plot twist in our story. That's right. The format wars, they're over. And it's not because one format won. It's because they've all agreed to work together. And the reason for this truce is a brand new technology. Meet Apache Xtable. And let me be clear, this is not a new fourth table format. It's a universal translator. Xtable reads the metadata from one format, let's say Hudi, and it automatically generates the equivalent metadata for both Delta and Iceberg. And it does this without ever copying the underlying data files. So what does this mean? It means you have one single set of data files that can now be read as a Hudi table, a Delta table, and an Iceberg table all at the same time. The implications of this are massive. You can now write your data with the format that's best for your ingestion, like Hudi's super fast streaming, and then let everyone else read it with whatever they want. Your data science team can use their favorite Databricks tools on a Delta table, while your analytics team uses a high-performance engine like Trino with an Iceberg table. It completely dissolves data silos between teams, and it basically future-proofs your entire data architecture. So, if they can all work together now, how do you even choose where to start? Well, that leads us right into our final section, choosing your format. The decision now really boils down to choosing your primary write format. So here's a simple guide. If your world is all about high-speed streaming and CDC, Hudi is probably your best bet because of its incredible write performance. If you're all in on the Databricks and Spark ecosystem, then Delta Lake is going to give you the most seamless and managed experience. But if your top priority is building an open, flexible, multi-engine platform for huge-scale analytics, then Iceberg is the clear choice. So, the ultimate takeaway here is this. The modern data strategy isn't about picking one winner to rule them all. No, it's about choosing the best primary format for your most critical write workloads and then using amazing interoperability tools like Xtable to enable multi-format read access for everybody else. And this all leaves us with one final fascinating question. Now that the format wars are over, the battleground has shifted. It's no longer about the format itself, but about the catalogs and the compute engines that are being built on top of them. The next wave of innovation is happening right now, in this new era of open collaboration.